Hello YouTube! Today we start a new project, but one that adds on to and works with my last one for my digital Aquarium Controller series. With a few modifications, you can easily use this smaller device as a standalone unit or even modify it for purposes other than an Aquarium Controller. We will use the low-lin ESP8266 MCU module to power a small controller for an additional aquarium. These are very inexpensive wireless modules that can be programmed and used like an Arduino. This project will integrate a few other small, inexpensive components along with the ESP8266. We'll use the tiny RTC DS1307 real-time clock module for timekeeping, connected to pins D1 and D2, the DS18B20 thermometer connected to pin D4, a 2-relay board using pins D5 and D6, a standard power outlet powered by the relay, a small power board to convert the AC line current to 5 volts DC, and finally, 3 LEDs and resistors on pins D0, D7, and D8. To begin programming, we have to connect our low-lin NodeMcu ESP8266 board with the Arduino to program it. The cloud-based Arduino Create site does not support this board, but the desktop client does, with some modification. So, if you haven't already, download and install the latest Arduino software. I'm using version 1.8.2 here. So open the Arduino application, go to File, Preferences. On the Board Manager line, add the URL for the JSON package listed in the video description and click Save. Now go to Tools, Boards, and Board Manager, then open the Board Manager interface. Finally, scroll down to the bottom and select the ESP8266 option. Click Install as shown. This will download and install all the boards and examples for the ESP8266 boards. Now that Arduino supports it, go back to Tools and select the proper board, and set CPU and upload speeds. For low-lin in NodeMcu 1.0, 80 MHz and 115200 baud. Connect the board to USB, choose your COM port, and you can test out the sample sketches. Okay, to start, I use the example sketch under ESP8266 Wi-Fi client. This example sketch connects to the SparkFun to pull data. However, I want to instead pull data from my local Raspberry Pi web server, so modifications have been made. However, if you want to build this standalone, you should be able to compare my code with the example sketch to figure out how to connect back to SparkFun or to anywhere else. There are a few main tasks I desire to have done over the wireless. Number one, it should connect to get the desired settings if at any time they are lost, such as after a reboot. Number two, it should check for any changes or commands. 3. It should periodically check and verify if the time is correct. 4. It should report back with temperature and heater status for data logging. And finally, number 5, it should be inexpensive and modular for easy repair and reproduction. I plan to build several of these, one for each of the other aquariums I have around the house. And I also want the code to be modular and generic where reasonable. So, on the web server, I'll have a separate folder and URL for each. By changing the client ID variable in the Arduino code, I can build as many as I like, with each reporting in a unique way. For the DS1307 real-time clock, I use the DS1307 NodeMcu library and tiny RTC module, just like with my main Aquarium controller. However, this library isn't included in the desktop Arduino build and must be downloaded and installed. I downloaded it from the Create website by searching in Library Manager, then selecting Download. You can do it that way also, or you may use the copy I include in my GitHub link in the description. Once you have the zip file for your library, it's simple to install. Just go to Sketch, Include Library, Add Zip Library, as shown. Then you can select the zip file downloaded in the Arduino software will extract and install it as needed. So, I've already coded this up and have the full version working out on GitHub. But let me walk you through the evolution, so that you may better understand how to do it yourself or to modify it. I started the demo Wi-Fi client sketch. Here you just need to set your Wi-Fi connection settings, upload it to the ESP8266, and test looking at the serial monitor. Next, we want to modify the sketch and read data off our Raspberry Pi web server. So, I created a basic text document and placed it on my Pi. Test that in your browser. If you can see it, the ESP8266 should be able to. Modified the sketch to connect to my URL and file path instead of SparkFun, and then remove the code from the main loop and make it a separate function, so it can be called and reused as needed. Test this with a serial monitor. You should be able to see whatever you put in the text file output from the ESP8266. Alright, now that we can read some data, we have to parse it into something that we can use. The first thing I notice is there are about 11 lines of headers, so I set up a counter and a conditional to skip past those. Then we take the string of data and parse it into local variables. I set up my sample data to be delimited with colons between each value, so I break it up based on that. With some trial and error, you should be able to output the serial data by the variable name instead of raw output. When that's the case, we can use the data for other functions. Alright, we need some good data to read now. Time for some web content. The time.php file is a simple PHP that outputs Raspberry Pi clock time, which we can use for synchronization. Settings.php will put the current configuration parameters from MySQL and output them for the ESP8266 to read. And finally, data.text, which we just created, can be written to by index.php when we need to send temporary data, such as light or heater interrupt commands. For timekeeping, the DS1307 was covered in episode 12 of my main controller series. We'll reuse most of that code here. For synchronization, rather than serial data from the Pi, we need to get the time from our time.php web page. To do this, I copy the poll web server function, name it to poll web server time, and modify the parsing to capture the data from time.php, and then set the clock. In episode 3 for the main controller, we cover the DS18B20 thermometer. I'll reuse that code and process here. To store the data in settings, I've created a new database called Devices in MySQL. You can download that from the GitHub, but this will be simple and smaller, so we only need a few tables. Each controller gets a conf table, and there's a single recent table for all data sent from the devices. When recent is updated, it also writes a new line to the respective log table for each device. Now we need to configure a PHP page to receive post data from the ESP8266 and record it in MySQL. Respond2.php parses the post and writes it to SQL or file based on the content. Alright, easy enough, but we need to code our ESP8266 to post the data to the Pi. I expected this to be easier. It proved to be painful. The web post respond function is similar to the poll web server function, but with a few exceptions. One, it takes the variable name, data, and prefix as passed variables into the function. 2, the content type must be specified as XWWW form URL encoded. 3, the content length header must be set and specify the proper length for the post data string. Once all of that was correct, it worked like a charm. The timekeeping, relay control, light control, and temperature control code were all borrowed from my main controller Arduino code. They were trimmed down a bit, as in many cases there was more functionality like dimming needed for the main controller. As each step, function, or component was added, it was frequently tested on the breadboard. I had this running alongside me the whole time. Here we have the final build with everything in place. You can see the status is reported and visible on the web page, index.php. Settings can be adjusted, and buttons can be clicked to turn things on and off. From here, we need to add relays, outlet, power supply, solder it up, mount it into a case. I'll cover all of that next time. But for now, I hope this was useful. Please post any questions or comments, and if you like this, please click like and subscribe. And as always, thanks for watching.